Section 2.1 is on basic set theory. There's going to be several definitions and symbols that you will need to get familiar with. A set is a collection of objects whose contents can be clearly determined. This is called well-defined. Set A could be the students in a class. It's considered well-defined because its contents can be clearly determined. Set B is a set of best cars is not well-defined because best can be interpreted differently. What you think is best is not what I think is best. Objects in a set are called elements or members of the set. This symbol right here that looks like a funny looking E is used to indicate that an object is an element of a set. So think about that looking like an E, so think of that as element. It is used to replace the words is an element of. The symbol, the E with the slash through it, is used to indicate that an object is not an element of a set. It is used to replace the words is not an element of. So let's take a look at some of these and decide if they're true or false. Is R an element of this set? Now, maybe you're not familiar with the ... in there. This means the set A, B, C, D, E, F, etc. all the way up to Z. So is R an element of that set? Sure it is. So that's true. Here's a set 1, 2, 3, 4. That's all it contains is 1, 2, 3, 4. Is 7 not an element of that set? No, it is not. That is a true statement. Now be careful with this right here. This is the set A is an element of the set AB. Now yes, there's an A and there's an A here, but we do not use this symbol with set notation. The squiggly parentheses around the A indicate that it's a set. So we do not use that symbol. So this is false. I could say A is an element of the set AB. Notice the subtle distinction there. There's no squigglies around the A. Capital letters are generally used to designate a set, and there's 3 methods that we use generally to designate a set. There can be a word description. So I can say W is the set of the days of the week. Or I can list them out in roster method. W equals Monday, Tuesday, Wednesday, etc. That is the set. Now, the squiggly parentheses always indicates that you're dealing with a set. Order is not important unless MathXL would specify that. And each element is separated by a comma. The squiggly parentheses are called braces, and that's what we use for set theory. We use the little squigglies. Set builder notation is the third way, and you should be familiar with this if you took 1033. Set builder notation is this, and what this translates as is the set W equals all X such that, that's what that bar stands for, all X such that X is a day of the week. So some of the problems you will deal with in MathXL will be to switch between these 3 forms. So these are 2 important sets of numbers that you will see several times in this chapter. N is the set of natural numbers, N for natural. It's the same thing as the counting numbers. The counting numbers begin with 1 and they go 2, 3, 4, 5, etc. Notice there's no fractions, there's no decimals. So anytime you see capital N, we're talking about these numbers here. This is an I, and what that stands for is the set of integers, I for integers. The difference between integers and natural numbers is integers also includes the negative numbers. These little dots right here mean this continues -4, -5, -6, etc. And the little dots at this end stand for +4, +5, etc. So when you see a capital I, you know they are talking about the set of integers. All right, example 1. B is a set of the members of the Beatles in 1963. The roster method means we just need to list them using your braces, putting them in any order you want. We have John, Ringo, George, not Gorge, George, and Paul. Close it off with braces. That's the roster method. The set builder method will have the same braces. It is all X such that X is a member, that's our E, is an element of the Beatles. In 1963. Here's a set that begins as set builder, and we want to switch it to roster method. Now, I have two different ways that you might see it written in this set builder notation. This is all x, such that x is greater than or equal to 16, and x is an integer. It's specifying in words that x is an integer, meaning no fractions, no decimals. Or it could say the same beginning, all x, such that x is greater than or equal to 16, and x is an element of the set I, which we now know is a set of integers. So the roster method is braces, and we want to start with the first number in the set. This is x greater than or equal to 16, meaning 16 is included, and then 17, 18, etc. So our three dots give us the etc. Close off your braces, and that is this same set written out in roster method. Another one that's in set builder notation, we want to do the roster method using a shortened method. This says x is a lowercase letter of the English alphabet. Well, you know there are 26 letters in the English alphabet. Who wants to write out all 26? Not me. So the shortcut on this is A, B, C, dot, 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 until we reach Z. And close off your braces. That's the shortened method. Instead of having to list all 26, we have written enough of the pattern so that someone could recognize that this is all of the letters of the English alphabet ending up at Z. We're going to write this one in roster form. This is telling us it's all x, such that x is an element of n. Do you remember what n was? N is the natural numbers, and our natural numbers were 1, 2, 3, etc. But we want our natural numbers to be the ones that are less than 3. Which of these are less than 3? Just 1 and 2. Not 3, because it says less than 3. 3 is not less than 3, it is less than or equal to 3. If it had said less than or equal to 3, we would also include 3 in our set. But it did not say equal, and that's why 3 is not in our set. A new term is the empty set, also called the null set. And it's exactly what it sounds like. It is a set that contains no elements. The empty set is represented either by this symbol, which is the braces with nothing in it, or this, which is a big O with a slash through it. Do not put this O with the slash through it inside the braces. That would indicate that we had a set that contained this funny looking symbol. So it's either this or this to show the empty set. You'll have a couple questions on MathXL that ask you which of the following would be the empty set. So this is all x, such that x is a number greater than 10 and less than 4. Well, is there any number that's greater than 10 and at the same time less than 4? No, that means there is nothing in that set. Therefore, this is the empty set. This has the braces and a 0 inside it. Does it have an element? Yes, it has 0 inside it. So this is not the empty set. Let's express these using the roster method. Set A is the set of natural numbers less than 5. Remember, your naturals are just going to be 1, 2, 3, etc. But we need them to be less than 5. So 1, 2, 3, 4. Should we include 5? No, because it's just less than 5. Put your back brace. Set E is all x, such that x is an element of the natural numbers, and x is even. So our even numbers, our first even number of the naturals is 2, then 4, then 6. And do we stop there? No, it continues. There is our set of even natural numbers. I have stars on this because there's a very subtle difference between this, the way this is phrased. This says set B is a set of integers between 13 and 25. When you just see the word between, it is different than between, and then you see inclusive. Between does not include that number of 13 or 25. So it starts with 14, 15, 16, keep on going, and we would stop at 24, not 25. So between means this number and this number are kind of like the bookends, but they're not part of the set. When you see this, the set of integers between -2 and 1 inclusive, that means our set will begin with -2 and it will end with 1. Now what's in between here would be -2, -1, 0, 1, I made that a little bit too large, but that's the idea. So inclusive means include that number in your set. Include that number in that set. If you don't see the word inclusive, you do not include 13. 13 is not part of the set. 25 is not part of the set. They are the bookends. Let's do these in roster method. X is an element of n. So at this point, when you see the n, you should be thinking, oh, we're thinking 1, 2, 3, etc. And we need it to stop at less than or equal to 100. Do you want to write all this out to less than or equal to 100? No, but we'll do our braces. 1, 2, 3. This is a good time to use our shortened method, dot, 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 out to, should we include 100? Yes, because it says less than or equal to 100. X is an element of n, which is the naturals, and this is saying X is between 70 and 100. Now, it doesn't use the word inclusive, but when you see this symbol, the less than or equal to, that means we do include that number, 70, 71, 72, etc. But notice this is just plain old less. Should the 100 be part of the set? No. What's the last number here? 99.